Okay, so I
Uh,
think we are. We will continue to admit people that are joining. You are all welcome. As we said, Dr. Andrew, Mr. Kanimo, and as many of us that are here, we've already made a brief introduction. Dr. Chinedu Izuchukwu is a lecturer in the Department of Mathematics, University of the Witwatersrand in South Africa, one of the ranking university in South Africa and also in Africa. And as I said, Dr. Izuchukwu is one of a young researcher that have made global impact. He's young in age, but in terms of research, is as old as any professor you can think about. So he has made a global impact. His papers, works cited all over the world, and he has done a lot of work also in that's variational inequality problems and other areas of functional analysis, where he has exhibited a lot of technicalities in MATLAB coding. So he's an authority. That's what we are trying to say in MATLAB coding. So it's quite a privilege to listen to him. So let's not take the opportunity for granted. So we want to formally welcome Dr. Izuchukwu. So Dr. Izuchukwu, you can commence right now. I think I can. Yes.
Yeah, thank you very much, Prof, for that wonderful introduction. I'm privileged to be here, and such an introduction. Yeah, I don't know what to say, but thanks. So I'm allowed to share my screen now, right? Can I go on?
Yes, you can. You can share your screen. Yes.
Okay. Apologies. My video, I don't know what's going on. I'm trying, even as you were talking, I'm trying to make sure that my video is showing. Except you guys can see me. I don't know. I'm trying, but it's not working. So maybe I just carry on without.
Yes, the most important thing, your audio is very audible. So even if we can't see your audio is very audible. So we are glad for that. So you can go ahead.
All right, all right. So let me share my screen, and then maybe you'll just let me know once you can see the screen.
Yes, I think we can.
So I'm on, yeah, I'm in the MATLAB environment. I don't know if you can see that.
Yes.
So, so at first I wanted to prepare a slide for this, but on the other hand, I thought maybe it would be better if we stick more on the practical aspect, because I can see for Zoom, we don't have enough time to talk about, and moreover, a lot of people must have seen things about the what MATLAB is all about, the whole introductory aspect and all of that. So the written part, the theoretical part, I don't think that's what we actually need. I think people want to see how this is done practically. So that's why I don't have a slide. So I'm just going to talk about the MATLAB as I talk, and then I try to write the code and everything and explain how the code works. Please, may I ask, there are some noise from background. If the person can mute, sorry, please.
Yes, yes, please. If only the presenter is allowed to, have his audio on. Mute. I'm going to mute those that are with us. So please, you mute your.
Okay. Can you hear me, everyone, please? Yes.
Yes.
Okay, thank you. As we go on, you can ask any question because it's practical. So we just have to make it interactive. So just ask wherever you want to ask anything, just ask. You don't have to wait until I finish. So I'm okay with that. So I'll just go straight to opening new window. Sorry about this. So I've been trying to close them. So I wanted to close all of this, but it's a lot. I would have done that before now. So this is a new window. So this is the MATLAB window. And for me, I am using MATLAB 2014b. It's an old version, but it does everything that I want. So I didn't see any need to install the latest one. But there is that for 2021 and 2022 also. 2022 RB. Yeah, there is 2022 RB. So if you want, you can download that, but it's not readily available. So I don't know how. So you can get that if you want, but it's just the same thing basically, because the environment looks alike, just maybe one or two features that will change, but at the end, it does the same thing. So like I explained, this is the environment. MATLAB does, before I go on, I believe that this might be a mixture of, I don't know the audience that I'm speaking to. So I want to assume that I'm speaking to beginners. By beginners, I mean people that have little or no knowledge of MATLAB. People intermediate, people that has considerable amount of knowledge, and perhaps people that have that are also very good, but they just want to also see if they can pick one or two things. So for the sake, because I don't know the particular audience that I'm speaking to, I'll try to be in between, try to carry everyone along. So for those that are experts, maybe there are things that we might be doing that might be too elementary, but I just wanted some people that doesn't have a clue of what this is all about to also follow. And secondly, I could also go a little bit intermediate. So those that are also struggling to learn, please pardon me, but you can ask me anything as we go on. So like I said, this is the environment. This is the MATLAB. It is called the editor. So this is where you write the codes that you need. For example, like I said, you can use MATLAB for a lot of things. They are like the engineers and all of that. But for the purpose of this, what concerns us here is how we can use MATLAB to run algorithms, right? Fixed point algorithms and optimization algorithms. So after explaining everything, at the end of the day, we will try out a very simple algorithm, the MAN algorithm. And if there is still time, we can also try some algorithms from variational inequalities, such as the projection and contrast, what's it called again, extra gradient algorithm and other variational inequalities algorithm. So if there is another opportunity for me to present, we can go deeper. This is so what we're going to do today is kind of a very simple iteration. We're going to try what I have explained on a very simple iteration. Okay, so this is the editor. This is where you write, for the sake of the algorithm, this is where, suppose we are looking at a MAN algorithm. So for a simple MAN is xn plus 1 equal to 1 minus alpha n xn plus 1 minus alpha n t xn, right? And then we usually have a starting point, say for n starting from 1, and then we try to run the iteration. We get for up to n to infinity. So such algorithm, you're going to use this environment, what you have here, to write the code itself. Now running it, for some people, they also run it here. I will explain what I mean by running. It is also called to call the algorithm. So you call it. They also do it here on this environment. But for me, because in many of our iterations, we try to compare algorithms, right? And because of that, I try for the call, I try to have a separate environment for the call, different from this. Because when I want to compare algorithm, it makes it easier for me to when I'm comparing algorithms. So some of the things that I'm going to explain, these are very trivial. The ones you can see my mouse going on, these are quite trivial. I don't know if it is better to leave the everyone on mute. I don't know if that's better. So it will be more interactive. But I hope it will not be noisy though. At some point, I feel like I'm talking to myself.
Yeah, no, they are listening.
Okay.
We are following you.
Okay.
Okay,
So
I'm trying to unmute everybody now.
okay, thank you very much. Sorry for
yeah.
giving you that job, muting and unmuting.
Okay.
Thank you.
Yeah.
All right. So this everything here shouldn't be a problem, because this is new, where you open a new script and all of this. This is to open a new MATLAB. Maybe there is one MATLAB you have, and then you try to find it here to open. Alternative to this is here. You can see these are other codes that I've written. So I can just come here and pick them up. But I've been trying to close them. So we just have a very, so all of this is not showing, but I don't know, there are so many. And then this is the document, but I would like to go straight to the environment, how the code itself works. This, I believe you can navigate. So what is very important here is this guy here, the run, when you want to run the code you've written. So this is where you do that. And another thing that is important is the save. You have to save what you've done, right? So this is what's important also. And then this is where at least you open the existing codes you've written, or here you can also do that here. And then that's it. Sorry, I didn't start from the beginning by launching it from the desktop, but I believe everyone can launch the software from the desktop. So let's start from the editor. Now, to write an algorithm, a code for an algorithm, you need a function name. So you need to give it a function name. At the end, I'm going to recommend a textbook where some of these things all this syntax are explained in detail, but it is quite big. So I don't know whether anyone would have time to read a textbook of about 300 plus with codes in them. So, but that's where I started. I didn't finish, but I started, I think I went up to the middle before I started practicing. So you need to have a function name, right? So let's start. So for an algorithm, I need a function name. So I type function, right? And then I would need, so you have an open square bracket. So now if you have an open square bracket, you need, because we have, for instance, the algorithm as xn plus 1 equal to alpha n xn plus 1 minus alpha n txn. So we want to see what we can call xn. Remember, xn depends on n, and then for each n, so we want to generate the algorithm. So I'll just give xn anything that I wish I want to call it. So let me just call it let's say X, right? Just something very simple. So this is my Xn now. So it is called X. And now, you remember, for those of us that, that's why I said I'm going to be a little bit higher. If you've been writing algorithms, right? You've been doing that. You should understand that when you usually terminate your algorithm at some point, and then that's where you get your error. So it depends on what you want to plot. If you want to plot error against a number of iterations, so you want to see what happens between the number of if you have your error on the y-axis and then you have your number of iteration on the x-axis. So as the iteration number increases, how does the error behave? So you want to see how long, how many iterations do you need before it terminates? So there is something we usually, it depends on how you want to define your error. Some people want to define their error as the norm of xn plus 1 minus xn. That's how they want to define their termination, what's it called? The error. For this algorithm, for the man algorithm, it makes sense because xn plus 1 minus xn, as it approaches 0, you see, we have something, so we see that, what's it called? The terms of the same sequence. So when it start coming closer, so you want to estimate the error as xn plus 1 minus xn goes to 0. So you want to see what's going on. And another way you can do this is you want to have the norm of xn minus x star as your error. And this makes perfect sense because if xn minus x star goes to 0, then you know that xn converges to x star. And this is what you want to do. You want to show that your algorithm converges to the solution of the problem. In this case, the solution of the problem is the fixed point of t, right? So you want to do that. Another way to calculate your error, for some people, you want to check xn minus txn. Your error is xn minus txn, right? So this also makes sense because if xn minus txn goes to 0, what does that tell you? It tells you that at some point, you see that if you have that x minus tx goes to 0, it means that x is what? The fixed point of t. That's where the idea comes from. So what I'm trying to say is that there are many ways you can compute your error. You define your error. That's up to you, what you are looking out for. But the most common one is to check what's going on between xn plus 1 and xn. So that error is what I want to write now. So I may call it ER, and then I close my bracket. And this must be equal to, I have to give this function a name that it will remember wherever I'm going to call it. Because for MATLAB, I can have many sub environments, and then they can connect themselves through the name that I'm going to give now. So here, since we're talking about man, so let me call it man, the name, and then I'll close this. Now, remember I said from the beginning, you need, for instance, if you have an algorithm, you need the starting point, right? So our starting point in this case, let's say it is x naught. And then the error, we want to terminate the algorithm at a particular point. So, and which is what we call the tolerance level. So let's call it the TOL. So you can choose your TOL to be 10 to power minus 3, 10 to power minus 2, 10 to power minus 1, 10 to power minus 4, 10 to power minus 5, depending on what you want, because you need to terminate the algorithm at some point. So that's where the TOL comes from. And now, having done this, I need this algorithm to run while error. Okay, I would like to differentiate this error with this one. So let me call this one ER1. So why this error ER, or I can call it ERR, whichever one you want to call it. So why ER is bigger than TOL. So why it is bigger than TOL, I will explain this in a bit. So I will now end the iteration. So now this is the standard environment. Now you can see that there is kind of red something underneath. That shows you that something is not right. So we need to do something. So what does that mean? So we need to connect. How does X relate to X naught? Remember, X is our Xn, and X naught is the starting point. So I would have to say that X naught is equal to what? X naught. At least for the first iteration. For n equal to 1, you need, or for n, since we are talking about X naught, so let's say for n equal to 0, or to avoid confusion, let's call it X1, and then let's call this X1. So for n equal to 1, I want to see what happens. But remember, if I have an iteration xn plus 1 is equal to alpha n xn plus 1 minus alpha n txn. Now, what do I need from this iteration? I need to know the starting point, x1. I need to know what x1 is. So I need to define x1. And suppose we are in R2. So let's do this in R2, please. So maybe I just make a comment here, so that everyone will follow that this is a test. So you can write on your, if you don't want your MATLAB to pick up something, you can comment on it just to tell you what you're doing. So and how do you comment? You use the $sign. So once you use the $sign, the MATLAB does not, when you run, it doesn't pick up that part. So it's just like a sentence. So we want to see, let's say tutorial for man algorithm in R2. All right. So we are in R2. So I need X1. I need to know what alpha n is, and I need to know what t is. So for n, this means that for n equal to 1, you would have to generate x2, because you already, for n equal to 1, you already know what x1 is, because by the time you define x1 and you define alpha n and you define t. So you can generate your x2 from your xn plus 1, because when you add 1 plus 1, you have 2. So this is what I mean. This is the algorithm we are looking at. So let me comment again. So we're talking about, I don't know how this will appear here, if you can read this. So we're talking about this alpha n plus alpha n xn plus 1 minus alpha n txn. Right. This is the algorithm we're looking at. So now I need to know what, so for n equal to 1, I can generate x2, right? Because when I put n equal to 1 here on this here, then I'll have x2, right? Because 1 plus 1 is 2, and then this will give me alpha 1 x1 plus 1 minus alpha 1 tx1. Yeah, and now because I will define x1 from the beginning, because I already defined x1 from the beginning, and I'll define alpha n from the beginning. So when I substitute 1 into that alpha n, I'll get alpha 1. And then I'll then plus 1 minus alpha 1. Okay. Can you still hear me, please?
Somebody is making noise.
Yeah, okay.
Yes, exactly.
Okay, so and then plus 1 minus alpha 1 times t x1. Already you need to know what t is. So having this information, now from the beginning, I want, for each iteration, I want my xn to be equal to x1. What does this mean? It means that because I already know what x1 is, right? From the beginning, I have to define x1, but I will define it elsewhere, not here. That's what I was talking about, creating two environments. So I'll define the initial point there. And then that's why I have something like this. So that at the end of the day, from the, when I'm writing this algorithm, my xn is equal to x1 for n equal to 1. I'm stressing on this so that you understand, because if you understand the basics, then the code follows. So for n equal to 1, my x is equal to x1, which is my xn in this case. So my xn is equal to what? X1 for n equal to 1. So this gives me the first iteration. And then we repeat the same thing for n equal to 2, for n equal to 3, and so on and so forth. Okay. So now, because I know this, I need to define what t is. So we can define, we need to know what t is. So suppose t is, for instance, I define t of x to be equal to x negative, so since we are in R2, so maybe I'll have something like negative x1. I'm talking about non-expansive map now. So negative x1, comma, x2. So this is non-expansive. Yes, this is non-expansive. So then I have this. And then I need to know what alpha is, alpha n. So alpha n, I need alpha n, bearing in mind rather, the conditions generally for alpha n. So let's take alpha n to be n plus 1 all over 2 times n plus 3. Yeah, so this is my alpha n. So now this is not on MATLAB. Remember, this is not part of the MATLAB code. It is just a comment so that you can follow what I'm doing. That's why you can see the $sign. You can see the $sign makes it appear in, I don't know color, so sorry if I get it wrong. This is green, right? It makes it appear in green. And so which tells you that this is not part of your code. It only helps you to remember what you're doing or make comments like I'm doing now. So in MATLAB, if I want to define t, since I'm in R2, which is very easy, all I need to do is write it as a matrix, right? So you can use operator transformation to do that. So this would just be, I believe everyone knows how this would look like. So this would just be, so ideally, this is supposed to be a matrix of this form. So let me write what the matrix should look like. So this is supposed to be negative 1, negative 1, negative 1, 0, if you write it as a matrix. Then you have 0, 1. So this is how it's supposed to look as a matrix. As a matrix. But in MATLAB, you just simply write this, negative 1, 0, and then you use, is it semicolon? Yeah. Then 0, 1. So this is what it will look, this is what it is in MATLAB. And now you observe that I usually use semicolon. I was expecting someone to ask me, but no one did. So you observe that I usually use semicolon at the end. It is not necessary. I may leave it. It doesn't change anything. But why I am doing that is that when I run my code, I don't want so many things to come out as a result. So if you don't want this to appear when you run it, when you want to generate your results, because for your results, you want to see the number of iteration, and then you want to see the time needed for the iteration to run. These are the things that you are interested in, and then you want to see how the graph looks like. Now, sometimes you want to see each of the xn, like for n equal to 1, you want to see what xn is. you may also leave that. But if I don't want to see, so other things, I'll just use the semicolon to suppress the output so they don't show. Because if you have so many information, then it's difficult for you to pick out what you need. So that's why I have that. Now, having said that, the next thing is, so this is your algorithm. So the next thing is you start your main loop. So I can call this my operator. And then I can call this my main loop. So I can start my main loop. So now, here, this is where this error plays, ER plays its role. So I want to start ER equal to 1. But first of all, I need to start N equal to 1, like
Dr.
we said.
Chinedu, sorry, before you continue, I have an announcement to make. I
Okay.
just got information that our time is maybe running out.
Oh.
That's the Zoom time. So once it runs out, I will generate a new code and paste in the Fanog platform, WhatsApp platform, so you can rejoin.
Okay.
That's in case the time runs out. Yes. Thank you.
Okay. All right. No problem. Thank you very much for the information. Okay. So this is the main loop. So we start N equal to 1, like I explained from the beginning. $sign. Okay, someone asked me a question. Why did I use $signs for operator? Okay, where is the $sign?
Sorry.
So please, can you be specific with the question? I don't know where the $sign is. Yeah?
Sorry, I'm the one. That operator, you are using 2 signs instead of 1. So why? Is it different from
the
others?
2. No, it's the same thing. Sorry, it doesn't matter. If you like, you can. But this, okay, you mean the percentage sign, right? This you mean sign. Here? Yeah. So yes, you can use as many as possible, but 1 is enough.
It's enough. Okay, thank you.
Yes, 1 is enough. Sorry. Yeah, thank you. All right. And then we have N equal to 1 and ER equal to 1, which is the error. So now I can comfortably explain what this while syntax mean. Here, like I explained from the beginning, the function here is to give the function name. And I have to, so in representing the function, this X would have to represent this guy here, X1. And X1, this X represents our Xn. And the X1 is for N equal to 1, the initial starting point, which you need to give. You need to give the initial starting point, ideally. So, and then you need also to terminate your iteration at some point. And then you terminate it using the tolerance level. So some people use 10 to the power -3, -2, and so on. And then this ER1 means your error, what you want your error to look like. If you want it to be the norm of xn plus 1 minus xn, that's your error. So now this means that as long as ER, so ER equal to 1 is different from this, please note. So it means that as long as this ER is bigger than TOL, at the end of the day, you see the connection between this ER1 and ER. But now, let's stick to this. As long as this is bigger than TOL, of course, because the idea is, since your TOL, at least for the first one, is going to run, because your TOL is usually 10 to the power negative, maybe 10 to the power negative 1 is 1 over 10, right? Which is 0.1. Sorry, I don't know this math. So, of course, it's 1 must be bigger than TOL. So it means that as long as this is bigger than this, run whatever I'm going to write here. Because this is where the main algorithm will be written. The code for the main algorithm will be written. All of this is just a preamble. What I mean by the algorithm is the algorithm with N. When you start having your xn plus 1 is equal to alpha n xn plus 1 minus alpha n txn. So that's where I'm going to write it. So this what this means is that it will continue to run this iteration, whatever I'm going to write here, as long as 1 is bigger than TOL. So it means that if your TOL is very small, the algorithm will run, you have more number of iterations. If your TOL is large, you will have lesser number of iterations, because if it is very small, of course, what you will get will always be smaller than, will likely be bigger than the TOL, sorry, since your TOL is very small. But if you have maybe 1/10, which is considerably not very small, so in that case, your iteration will terminate faster. So let us, having said this, I want to define you will observe that I didn't define my alpha up here because I need to define the entire alpha n. So I'm going to do that here, where the main iteration is. So my alpha, I can call it AL alpha proper if I want, or I can call it AL for the sake of convenience. So I'll define it as n+1 divided by 2n plus 3, like we did up here. However, observe that I cannot write this. You can see for MATLAB, it is very sensitive. So you